The Cogitating Ceviché presents Extended Reality, XR, for Training, Immersive Learning Experiences by Conrad Hannon and Mauve Sanger. Narration by Amazon Polly. Introduction to XR Technology. Extended Reality, XR, includes virtual reality, VR, augmented reality, AR, and mixed reality, MR, offering immersive environments that merge the physical and digital worlds. XR technology is transforming training and education across various industries by providing hands-on, risk-free learning experiences that are both engaging and effective. VR creates completely immersive environments by replacing the real world with a simulated one, allowing users to interact within a controlled and safe digital space. This technology is particularly beneficial in scenarios where real-life training could be dangerous or impractical. For instance, in surgical training, VR can simulate complex medical procedures, enabling medical professionals to practice without the risk of harming patients. Similarly, in aviation, VR flight simulators allow pilots to experience and respond to a wide range of situations, including emergencies, without leaving the ground. AR, on the other hand, overlays digital information in the real world, enhancing the user's perception of their surroundings. This technology is often used in manufacturing and maintenance training. For example, AR can guide technicians through complex repair procedures by overlaying step-by-step instructions and highlighting specific parts of the machinery. This improves accuracy and reduces the time required to perform these tasks. MR combines elements of both VR and AR, allowing real and digital objects to interact. This hybrid approach provides a more flexible and interactive training environment. MR can bring textbooks to life in education by enabling students to interact with 3D models and simulations. This interactive learning experience helps students to better understand complex concepts and retain information more effectively. Using XR in training and education is not just about making learning more engaging. It also offers significant practical benefits. By providing a safe and controlled environment for practice, XR reduces the risk of accidents and mistakes. It also allows for repeated practice without additional costs or resource consumption, making it a cost-effective solution for skill development. XR technology is set to revolutionize learning and training, offering new possibilities for immersive, interactive, and effective education across various fields. Applications in different industries. Healthcare. In healthcare, XR technology enhances surgical training by allowing medical professionals to practice complex procedures in a simulated environment. This approach reduces the risk of errors during actual surgeries and boosts the precision and confidence of surgeons. For example, VR simulations can replicate the conditions of an operating room, enabling surgeons to refine their techniques in a controlled setting. Additionally, medical students can use VR to simulate patient interactions, improving communication and diagnostic skills without real-world consequences. This training type helps students practice bedside manners and diagnostic questioning in a realistic but safe environment. Aviation. XR technology revolutionizes pilot training using advanced flight simulators that provide realistic scenarios. These simulators allow pilots to experience and respond to a wide range of situations, including emergencies, without the associated risks. By immersing pilots in lifelike environments, XR helps build their decision-making skills and reactions under pressure. Moreover, Arkansas can guide aviation technicians through maintenance procedures by overlaying digital instructions onto physical components. This ensures accuracy and efficiency, allowing technicians to perform complex repairs and maintenance tasks with greater precision and reduced error rates. Manufacturing. In the manufacturing industry, XR can simulate assembly line operations, helping workers learn how to use machinery and assemble products correctly. This leads to reduced training times and fewer errors on the production floor. For instance, VR can create detailed simulations of factory environments where workers can practice operating machinery and assembling products. Additionally, VR environments can replicate hazardous situations, allowing workers to practice safety protocols and emergency responses in a controlled, safe manner. This training helps ensure workers are better prepared for real-world scenarios, enhancing workplace safety and efficiency. Education. XR brings educational content to life in classrooms, enabling students to interact with 3D models and simulations. For example, students can explore the human body in detail through VR, which provides an immersive learning experience that is both engaging and informative. Virtual field trips to historical sites or distant geographic locations allow students to experience these places without leaving the classroom. XR provides hands-on experience in engineering, art, and science, democratizing access to high-quality education and resources that might otherwise be unavailable. This technology helps bridge the gap between theoretical knowledge and practical application, making learning more interactive and effective. Democratizing education and skill development. Accessibility. XR technology can potentially make high-quality training accessible to a broader audience. It can provide educational and training opportunities to individuals in remote or underserved areas, eliminating the need for physical presence. This capability is precious in regions with limited access to specialized training facilities and expert instructors. By leveraging VR and AR platforms, learners in remote locations can participate in immersive training programs that would otherwise be inaccessible. Additionally, XR can significantly lower the overall cost of education and training programs by reducing the need for physical materials and travel. Traditional training often involves significant travel, lodging, and physical resources expenses. XR eliminates these costs by delivering training directly to the learner's environment, making education more affordable and accessible to a larger population. Engagement and retention. Immersive experiences offered by XR are more engaging than traditional methods, leading to better retention of information and skills. The interactive nature of XR allows learners to actively participate in their education, which enhances engagement and motivation. For example, medical students using VR to simulate surgical procedures are more likely to remember the steps and techniques involved due to the hands-on experience. XR can also tailor training programs to individual needs, allowing learners to progress at their own pace and focus on areas where they need improvement. Personalized learning paths ensure learners can revisit challenging topics and practice skills until they achieve proficiency. This adaptability makes XR an effective tool for diverse learning styles and paces, fostering a more inclusive educational environment. Scalability. XR can train large numbers of individuals simultaneously, making it ideal for industries with high turnover or the need for rapid upskilling. Traditional training methods often struggle to accommodate large groups efficiently, but XR platforms can scale effortlessly to meet the demand. This scalability is crucial for sectors like manufacturing and healthcare, where continuous skill development is essential. XR platforms can be updated with new content and scenarios, providing continuous learning opportunities and keeping skills up to date. The dynamic nature of XR allows for integrating the latest industry practices and technological advancements into training programs. This ensures that learners are always equipped with current knowledge and skills, enhancing their employability and effectiveness in their roles. Extended reality, XR, is revolutionizing the way training and education are delivered across various industries. By providing immersive, engaging, and accessible learning experiences, XR has the potential to democratize education and skill development, making high-quality training available to a wider audience. As XR technology continues to evolve, its applications and benefits are likely to expand, further transforming the education and professional training landscape. Conclusion: Extended reality (XR) is reshaping the training and education landscape across various industries. By integrating VR, R, and Mr., XR provides immersive, hands-on learning experiences that are engaging and effective. In healthcare, aviation, manufacturing, and education, XR enhances the precision and efficiency of training programs, ensuring that learners acquire practical skills in a safe, controlled environment. The potential of XR to democratize education and skill development is profound. It makes high-quality training accessible to individuals in remote and underserved areas, reducing costs associated with physical materials and travel. XR also fosters greater engagement and retention through personalized and interactive learning experiences, allowing learners to progress at their own pace and revisit challenging topics. Moreover, XR's scalability allows it to simultaneously meet the training needs of large numbers of individuals, making it ideal for industries with high turnover or rapid upskilling requirements. The ability to update XR platforms with the latest content ensures that learners remain equipped with current knowledge and skills, enhancing their employability and effectiveness. As XR technology continues to evolve, its applications and benefits are likely to expand, further transforming the educational and professional training landscape. By providing accessible, engaging, and scalable learning solutions, XR promises a more inclusive and efficient approach to education and skill development, making high-quality training available to a wider audience. Thank you for your time today. Until next time, stay gruntled and stay safe.